All right, hello, this is Radicals handout number 2. And we're going to go down the middle again. I encourage you to try some on your own if you want to as I go through this video, but this is for your benefit here. Oh, it looks like number 10 kind of printed off kind of funny. I believe that's a 1/2 under that square root there. So sorry about that. Also looks like we've got a squared right there. Okay. Well, back to the middle here. Class, across the top, you should probably write multiplication and division are closely related to radicals. Now, when I say that, what I mean is that if you have square roots multiplying, they will simplify. They'll simplify. So with addition, with multiplication and division, it's closely related. You can actually simplify those radicals. If you got addition and subtraction, they're not closely related, and you got to be really careful. Majority of the time, you cannot simplify those. Okay, they will not simplify, and we'll talk about that more as we go along. So on number 3, they're both square roots. They're multiplying, so you can go ahead and simplify it. Make it square root of 4x squared. And 4 is a perfect square, x squared is a perfect square. Our answer is just 2x. On number 8. Now recall that 2/3 square root of 24 is actually 2/3 times square root of 24 times 9 times square root 3. In actuality, what we're doing is the commutative property. We're going to rewrite the order of these things so that the 2/3 and the 9, they're on the same kind of level. They'll multiply together and simplify. And the square roots are on the same level. They'll multiply together and simplify. So, long story short, 2/3 times 9 is going to be 6. Square root of 224 times square root of 3 is 72. And then we get to break up 72. 72 is, let's see. Oh, well, you know what? 36 and 2 is going to be the best way to go, I think. I was going to try some other things. But 36 times 2 is the best because square root of 36 is 6. So we got a 6 on the outside. It's going to multiply with the 6 coming out from that square root of 36. Square root of 2 left over. 36 square root 2. Well, class, we've actually been using this idea for a while, but it's just kind of in reverse here. We've undone squaring by square rooting to solve for x. Okay, we've done that before. Well, now we got a square root 5, but it's raised to the second power. Well, they're inverse operations. Square roots and squaring are inverse operations, so they undo each other, leaving us with a simple 5. On 18, here's the thing, class. I should mention this. I should have mentioned it earlier, actually. Some people have a strong desire to simplify these radicals at the beginning and then multiply. I would suggest against that, because oftentimes what happens is, yeah, you will be able to simplify this, make it a square root 3 and then multiply. But quite often, you'll then again have to simplify your radical at the end. So I encourage you to go ahead and perform the operation first, then simplify at the end. So on 18, we're going to get 3 times 18, which is 54, a squared and b squared. So the a squared and the b squared, they don't simplify, so we just write them together. Now 54 is 9 times 6. We've got some perfect squares going on, don't we? 3ab square root 6. Let's flip it over. We'll go to 23. Well, class, addition and subtraction are not closely related to radicals. The square root 7 plus the square root 3 will not simplify. If you don't believe me on that, try it out with a calculator. Get decimal values. Type in square root 7 plus square root 3. Get that decimal. Write it down. Suppose that you could add these together and get square root 7, square root 3. So make it square root 10. Well, punch that into your calculator. It will not equal what you put in for square root 7 plus square root 3. They are not the same thing. So they do not simplify that way. So we're stuck with these being separated. With that parentheses, that 5 just gets to multiply with them. Now notice 5's not on the same level with radicals, so you just write it as 5 square root 7 plus 5 square root 3, and you're done. Nothing more to do there. Oh, 26 is special. Do you remember? Do you recognize what that is? We've done this before, actually, this year. These are conjugates. So when we multiply this out, my money is on the fact that the middle terms will be opposites and cancel each other out. But you don't have to take my word for it. Let's just distribute it. We'll get 25 minus 5 square root 3. Distribute. Positive 5 square root 3. And then minus square root of 9. So in the middle there, sure enough, those are opposites. They go away. We're going to be left with 25 minus square root of 9 is 3. Well, heck, we just got 22, don't we? On 29, you're dividing. Again, class, don't try to simplify this before you perform the operation. Do that first. So, but since we're dividing is closely related to radicals, so we can go ahead and simplify this. We will get square root of 150 divided by 3, which is 50. 25 and 2, square root of 25, or perfect square 25 is, and so we get 5 square root 2. On 32, ladies and gentlemen, pretty soon you're going to have to rationalize denominators, but don't do it until the very end. We've got some operations to perform here. We want to divide first, then you can simplify and rationalize your denominator if you need to, but you may not need to. In this case, you won't. 14 divided by 7 is 2. Those will divide. The radicals will divide. You'll get square root of 75. The 2 will multiply with the 5 that comes out, leaving behind a square root 3. $35. 5 divided by 10 is 1/2. Square root 24x divided by square root 6x will be square root 4. The x's divide to make 1. Square root of 4 is just 2. That's why you do math right there. Check that out. That awful looking thing is just 1 right there. 48. Again, don't try to rationalize the denominator. Go ahead and divide. 1/2, not 2, right? 1/2. 4 divided by 8. And then divide 48 by 3. I believe that's 16. Square root of 16 is 4. Half of 4 is 2. All right, there you have it. Thanks a lot. Finish the rest of it for homework.